Okay, so here we go. This is proving trig identities, and so I'm going to go ahead and just start over again. But we talked about the step process and going through and proving these, and we're going to see each of the different tactics in that step process showing up on these 4 problems. And then I'm going to have you work in groups on trying some methods. Yeah. For proving trig identities?
Yeah.
Well, my primary purpose in having you do this is to use the ones that you need to know, but we use them for substitution and algebraic simplification. That's what they're used for. Now, these ones I gave you, you wouldn't use.
Okay.
These are ones that I've constructed to get you to practice the ones that you would use. Okay. So, good question. But, yeah, these you wouldn't. So, the process that we're going through is we want to take the more complicated side here, which we decided on number 1 was the left side, and then make it look like the right. One of the things to look for is if you have fractions in your more complicated side, is go ahead and join them together as a single fraction. That's one of the first things I would recommend you do. So that's what we did. It is, we took 1 minus sine squared of theta over 1 minus cosine theta. And what we did is we multiplied that 1, top and bottom, by 1 minus cosine theta in an attempt to get a common denominator. So it looks like this. We have 1 minus cosine theta over 1 minus cosine theta times 1 minus, we did, sine squared theta over 1 minus cosine theta. Okay, so that's where the first technique that we use is just finding a common denominator. You're going to do that quite often. So we have on the top, if I distribute the 1 here, it's just 1 minus cosine theta minus sine squared theta all over 1 minus cosine theta. So now I have a single fraction rather than a whole number minus a fraction. We have that 1 minus the fraction. Now, this is where we're practicing what we've been learning. We learned that, this is the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. You're going to use this over and over and over again here as you go through these ones that I'm giving you. So somehow there must be a way to rewrite this so that we have it just in terms of cosine. I don't have any signs in my answer. Somehow this must get canceled out. So how could I rewrite what I've boxed here so that I could substitute in right here? Yeah, so subtract the cosine squared theta over, and I'll have sine squared theta equals 1 minus cosine squared theta. Yes? Of the notes? This you have to memorize. There's nothing. This is a Pythagorean identity that you need to have memorized and then be able to use. So I could kind of put this off to the side. Let's just do that. So what we're going to end up using is this one right here that I'm circling in red. We're going to replace sine squared theta with 1 minus cosine squared theta. So 1 minus cosine theta minus, and then in parentheses I'm going to replace sine squared with 1 minus cosine squared theta. And down here I have 1 minus cosine theta. And I'm leaving the parentheses on there for a reason. You'll see why in just a minute. So if I distribute here, I have 1 minus cosine theta minus 1 plus cosine squared theta all over 1 minus cosine theta. So you can see here that the 1's will disappear. They cancel the equals 0. And if I rewrite the top, I have cosine squared theta. I'm just going to change the order, move the positive term out in front, minus cosine theta over 1 minus cosine theta. And the top of this can actually be factored. There's a GCF, or greatest common factor, of cosine theta that I can pull out. And when I do that, I'm left with cosine theta. I'm missing sign here. Let's see. Let's see, minus cosine theta. Okay, better yet, I'm going to pull out a negative cosine theta. Watch what happens when I pull out a negative cosine theta. That's what I was trying to prove anyways. If I pull out a negative cosine theta, what's left here? Negative cosine theta. And what do I have as my second term here? Positive cosine theta. Actually, not positive cosine theta, it's positive 1. Let's try that again. So positive 1. Let's put parentheses around that. On the bottom, I have 1 minus cosine theta. So once again here, guys, I pulled out, just so you can see it, a negative here, and that's because in the original problem, I have a negative up here. And when I was trying to pull out a cosine theta here, positive, it wasn't matching the bottom. The terms were the same, but the signs were opposite. So that keyed me into, I need to pull out a negative cosine theta. Now look at these two. They aren't written in the same order, but because of the commutative property of addition, we see that these are equivalent. Negative cosine theta plus 1 is the same as 1 minus cosine theta. So I can cancel, and look what I'm left with. Equals negative cosine theta. And I'm done. Okay, I've proven that 1 minus sine squared theta over 1 minus cosine theta is equivalent to negative cosine theta. So if you happen to see an expression or an equation with 1 minus sine squared theta over 1 minus cosine theta, and you remembered this identity, which you probably wouldn't, you could swap it out for negative cosine theta. That's kind of the purpose of these. But you would never use these aren't ones we would memorize. But the general purpose is for algebraic simplification. That's what these identities are for. Yeah. So we're supposed to find gradients. No, we're just done. It's a proof. Yeah, we're just proving that the left side equals the right side. So starting with one side, the more complicated side, we're going through the algebraic process to show that it equals the other side. I'm not. I'll leave it right there. Go ahead and finish copying that down. You could probably argue that, starting with the right-hand side, we're going to end up using the same technique regardless. Okay. So here we have secant delta minus tangent delta. That's what I'm going to start with. So I'm going to write down secant delta minus tangent delta. And then there are no fractions involved here, so I'm not, at least on the one part that I'm starting with. So the second thing on there, third, I think it's the third line on there, is I suggest you rewrite in terms of sines and cosines. See that on there? On the very top of the note page. So we're going to rewrite this as 1 over cosine of delta minus sine delta over cosine delta. So we're just rewriting that. Now, what we're going to find here is that now we've introduced some fractions. This wasn't terribly helpful. We probably could have started either side. We're going to have to do the same little algebraic technique that I'm going to show you next. Secant is defined to be 1 over cosine.
Oh, okay.
So I have 1 minus sine delta over cosine of delta.
Talking just about the left side. So secant equals 1 over cosine of tangent to sine. And that's just the left side. I thought it was like trying to get to the right side right now.
No, what I'm trying to do is start with the left side, do a series of algebraic steps, and then get it to equal the right-hand side. Yeah. Flip what? And then.
Right side.
Well, I didn't flip it. What happened is when I rewrote this on the left-hand side and found a common denominator, it looks kind of similar to the right, but it is flipped in terms of signs are different, huh? And also the sine is on the top, the cosine's on the bottom. There's a technique that you will use to be able to rewrite this. And we could have done this with the right-hand side right off the bat, and then work backwards.
We're still not on the right side, correct?
We're not going to deal with the right side at all. We're just starting on the left side. And we're going to do algebra and maybe some trigonometric identity substitutions to get to the right. So when we go through the process, it's not good form to work both sides down to something that is not equivalent to either of the original problems. Okay? So we're going to start with either one side or the other. Use only algebra and the trig identities we know, primarily Pythagorean identities right now, to rewrite the one side as the other side. So when I get to this point, there's a little, I would label this as kind of a more obscure trick, but I really wish I had a 1 plus sine theta in here, of delta in here. I need that. I can actually introduce that to the problem. It's kind of like the conjugate trick back in Algebra 2 with complex numbers. It looks like this. We take, this thing's messed up now. Let's try that again. So we take just a minute here. So we're going to take 1 minus. All right, so here's the trick, guys. We're going to take the original, this right here, the 1 minus sine delta over cosine delta, and we're going to multiply each side by kind of like its conjugate, the 1 plus sine delta over 1 plus sine delta. And what keys me into doing this is that I need to somehow introduce a 1 plus sine delta to the equation to make it match the right-hand side. Somehow I need a 1 plus sine delta. So what I'm doing, this is what we call the wishful thinking method. I wish I had a 1 plus sine delta in there. Well, I can, as long as I put one in the top and the bottom, because I'm really just multiplying by a very carefully chosen value of 1, right? So here's what I have. It's, if I distribute here, what's the top going to be? Do you see what it'll be? What's the first term going to be? 1. What are the middle terms? What's going to happen to the middle terms? And what's the last term going to be? And on the bottom, okay. On the bottom, if I distribute, I'm going to have cosine delta plus cosine delta sine delta.
Okay. Explain that to me.
I'm distributing. Cosine delta times 1 is cosine delta. Cosine delta times sine delta is cosine delta sine delta. Okay?
Yes, that took me a while. Sorry.
Okay, so now, once again, guys, we have an opportunity to use a Pythagorean identity. Do you see it?
Oh, yeah.
What is 1 minus sine squared of delta equal to? Cosine squared delta. Oh, one other thing I can do here. Let's do this next. What can I factor out of the bottom? What's a common factor in the bottom? So I should have just left it in the first place, right? So cosine delta and 1 plus sine delta. Okay. I should not have distributed. These guys would have been less confused and would have been in the same place as where we are now. So I factored out a cosine delta from each one. It probably would have been better to leave it in this form. As a matter of fact, it's good practice because we need to cancel something here. One of the cosine deltas here cancels with one of them up here, leaving me with
Cosine delta. Oh my god. Around your genius.
Number 3. What algebraic technique do you think we need to use on number 3?
Mods.
Lots, yeah.
Whoa, that's way off. Can't you just cross?
Or you could do it to the
So we're going to start with the left-hand side. 1 minus sine x over cosine x. Plus, I just copy it down again. So I'm just recopying the problem, deciding on which side I'm going to start with. Okay. Then I place my equal sign, and I am going to find a common denominator to join these together as one fraction. So I'm going to take 1 minus sine x over cosine of x, and I'm going to multiply that by the denominator of the other fraction, 1 minus sine x. So I'm multiplying top and bottom of this one by 1 minus sine x. And then I'm going to take cosine of x over 1 minus sine x. And what am I going to multiply top and bottom of that by? Yes, cosine of x. Okay, so I'm finding a common denominator. That's it. What's the least common multiple of these two? It's both of these together. So I've got to multiply this fraction by 1 minus sine x, top and bottom, and this fraction by cosine x, top and bottom. So up here, I need to be careful up here. This one is not a difference of squares. It's going to have 3 terms. 1 times 1 is 1. Then I have negative sine x and another negative sine x, which is minus 2 sine x. And then plus sine squared x. And that's the top part of the first fraction. Now I'm drawing one long fraction bar because this is all going to be over the same thing. Cosine x, 1 minus sine x. And then right here, this is just plus cosine squared x. So all I'm doing is multiplying top and bottom by whatever I need to do to get a common denominator.
Okay, so why is it negative?
Because by the distributive property, 1 times negative sine x is negative sine x, and negative sine x times 1 is negative sine x.
It's got that click. I don't distribute it.
So to answer your question, James, you could replace the sines with u's and the cosines with b's or something, and then simplify it. This goes back to finding common denominators with rational expressions that we do usually towards the end of algebra 1. So you're finding a common denominator like you have
1 over 2 and then 3 over 4.
Yeah, 1 over 2, 3 over 4. That's in arithmetic. To make it algebraic, you have 1 over x minus 2 plus 3 over x plus 3. So the two bottom pieces are different factors. They don't divide into each other, so you take the product of these common denominators. All right, watch this, guys. If you group these What does that equal?
One. Oh, I don't know. One.
Okay. Sine squared x plus cosine squared x equals 1. So 1 minus 2 sine x plus 1 all over cosine x times 1 minus sine x. Okay. And 1 plus 1 is 2. So we have 2 minus 2 sine x over cosine x times 1 minus sine x. Notice I'm not distributing this time. What can I factor out of the top? 2. I'm left with 1 minus sine x over cosine x times 1 minus sine x. So factor 2 out of the top. The opposite of it. So here, I can cancel out these. And what is 2 over cosine of x equal to?
Well, no, it's 2t.
Yes, which is what I was trying to prove. All right. All right, so on number 4, we're going to start with the left-hand side, definitely the more complicated side. And the first thing I'm going to do is rewrite cotangent theta as cosine theta over sine theta. And I'm going to rewrite tangent theta as sine theta over cosine theta. And it's off again. So I'll do the best I can. Might not be very good. Yeah. Yeah. So we have. Yeah, I can't do it. It's not working here.
The eraser, so you put it out.
That's like we did the last time.
Yeah. That orientation, okay. Okay.
Exactly.
Okay. All right, so we have sine of theta.
No. Oh yeah, look at that.
Yeah.
Whiteboard.
All right, so on this one, after you replace cotangent and tangent with cosine theta over sine theta and sine theta over cosine theta, we're going to distribute. Okay? Okay, so when I distribute, the sines here cancel, leaving me just cosine of theta. And then plus, when I distribute here, it's sine squared theta over cosine theta. And now I'm kind of back in the same position I have been for several of these, is I've got to find a common denominator. But when I go to find a common denominator here, by multiplying top and bottom of this by cosine of theta over cosine theta, that will introduce a cosine squared to the top. The bottom of what? Because the sine cannot cancel with cosine. Here it canceled with sine, leaving just cosine. Here, when I distribute sine theta times sine theta is sine squared theta over cosine. So what I end up with is cosine squared theta plus sine squared theta over cosine theta. And what is cosine squared theta plus sine squared?
1.
So we have 1 over cosine theta. And what's 1 over cosine theta? Secant theta. It will once you've